All right, folks, welcome and thank you very much for joining us today in our DVT Intellect Readers class. What we're going to be doing today is basically going through what I like to call a thorough introduction into the reader tools and what kind of things you can do with them and how you're going to do those things, how you get them set up to enable you to know what you're doing when you're working with these tools. The first thing I'd like to do, though, before we jump right into that stuff, is actually just get to know you a little bit and help you understand where my background is and who I am within Cognex. So to be fair, I'll start us off here and go through the introductions. I'd like to know your name and the rest of this information. My name is Miguel Perez, and I am the manager of education services here at Cognex. So my primary responsibility is to make sure that all of these systems for students or customers who want to learn about our products are available to them. We'll introduce you to a lot of the different methods we go about doing that later on at the end of the class. I do work for Cognex, and my location is out of Duluth, Georgia, which is our distribution center. I spoke about my role, and the application experience that I have is mostly through technical support, where I spent about 3 years working with customers on-site, over the phone, over email, just helping them get up and running, or if they ran into something, I helped them get around it or work through it. And my vision experience comes from most of that. I have probably about 7 years or so with Cognex now, so most of my vision experience is with Cognex products. And anything else, I throw that up there, give you something, I don't know, a little different, a little funny to talk about. And my anything else for today is that I am actually, believe it or not, teaching this class to you from Walt Disney World Resort. So I'm actually out here, and I wanted to jump into the class and make sure that it was covered for everybody that was signed up. And I'll see if I can catch a few shows after we're done here. So if you don't mind, I'll go ahead and pause recording, and I'd like Jessica to start us off and introduce herself, and then we'll move on to Mark, and then Rick, if you don't mind. All right, so here are the objectives. We're going to get to know different things pertaining to direct part marking strategies and objectives, and we're going to talk about the reader tools and apply them to some sample images that I have here. I'll show you what they look like when they're all working the way they're designed to work, and then I'll show you how you go about building them so that they work in that manner, in the way that they're designed to work and in the way that you expect them to work. We're going to talk about 1D readers, 2D readers, and optical character readers, or OCR as they're oftentimes referred to. Now, the reader tools are basically designed within the Intellect product, specifically within the DVT cameras, to allow you to very quickly and effectively decode machine-readable code. This is basically another way of saying these cameras can very quickly decode barcodes, 2D matrices, and read characters very, very quickly and very, very reliably, so that you can take either something that is in an extreme environment or something that just happens way too quickly for a human to be able to read accurately, and put a camera on it and have the camera provide you with very, very fast execution as well as very reliable execution. So if you take a look at each one of these individually, we'll talk about 1D readers, and basically they're used to decode marks that are designed to be read using one major direction. So as you move in the X or the Y axis independently, you might find actually 1D or linear readers that have what appear to be 2 dimensions, but when the code is actually, or when the camera is actually trying to read them, it's actually moving only in one direction at the same time. So that's why they're still considered. And most of the popular ones are UPC. You're probably very familiar with those. You see them probably every day. And the PDF 417 codes, these are becoming a little bit more popular just because you can fit more information into them with a little bit less real estate. And we'll talk about all of those factors later on. But you might actually have seen one of these PDF 417 codes that I'm talking about here on the back of the latest set of licenses that states are issuing, so that they can get the information from them very, very quickly. Over on the far right side, what you're seeing here is actually a list of the very many one-dimensional codes that are available to you as part of the Intellect product. The 2D or two-dimensional codes are a little bit different, and their primary advantage is that they can fit even more information into a smaller space, and they are read in 2 dimensions using both X and Y. And what you're going to find with these is that they're also going to be a little bit more durable or robust when it comes to actually holding on to the information under extreme or adverse conditions. And then finally, we'll talk about OCR, or optical character recognition, which basically allows you to print characters, alphanumeric characters, on some label, some surface, something, somewhere, and have the camera very quickly read that back to you, or if you need to, actually verify that a particular set of alphanumeric characters are printed. So it's not just good for telling you what's there, it's also good for telling you, hey, what you expect to be there is what is there right now. So we're going to do that as well. All right, so when it comes to all of these readers, it's all part of a larger initiative from manufacturers nowadays where they're taking this very, very seriously, and it's called direct part marking. And it's a process of basically taking a code or some mark or some piece of text and putting it on a part, and for very many purposes. That includes tracking those parts, making sure that you're able to identify those parts throughout every single component of their manufacturing process, and even once they get out into the consumer's hands or into the product's assembly. Direct part marking is used for all of those things that I mentioned, and it's used by many industries, not just the labels that you might see at the supermarket. It's used by the automotive industry, by the medical industry, specifically on surgical tools, the Department of Defense, as well as aerospace industry, very, very popular. And of course, some of the folks that originally started using this technology and have been using it for a long time now are the semiconductor manufacturing industries, because it's very important for them to track those parts, and they're dealing with parts that are very, very small, and real estate is a major, major commodity to them. So these parts allow them to take advantage of their functionality. For the purpose of basically error proofing, making sure that things are being assembled at the right time with the right components, tracing those parts throughout the manufacturing process, even once they get out to consumers or to the bigger assembly components, and also making sure that parts are authentic. A lot of folks are trying to make sure that their parts are not being pirated or copied or stolen, basically. And also for increased productivity, one of the things that you'll find once you start analyzing this direct part movement closer and closer is that when it comes to taking information from a part into a computer system, it's a lot more reliable and a lot more quickly done when you're using one of these cameras to get that across. So one quick example here is basically just the minutes or the time it takes for somebody to scan a full set of characters into a computer system. That includes reading it as a human and then typing it into the system, versus what it would take one of these cameras, even under very adverse conditions. You can see that one of these peaks is a little bit higher, but that's still significantly lower than the same peak in the other end. So that's what you're seeing here, a little bit of data showing us that it makes sense to move into this if these things are important to you. So the 1D readers, and how did we use them and take advantage of them? Well, the first thing I actually want to do is jump out of here and show you these 1D readers in action. So what I have here right now is the actual Intellect software, and in the Intellect software, I'd like to just show you basically what it looks like when these are working properly. So I'll put this into play mode and just show you that I basically just went through and I have all of these parts kind of changing position. They're not doing anything dramatic. They're just kind of shifting around in a clockwise movement if you keep your eye on them. But what we're doing in each of these frames is that I'm tracking the location of the part or the location of each code, and then at the same time I'm actually using a tool to tell me what is encoded into that code. So basically what I have highlighted down below is the actual tool that's being used. Let me just pause this for a moment. And this particular tool right now is the one that is currently highlighted in the image here with a blue outline. And what you're seeing here is that the code is actually able to be decoded, and that's what you see here as part of the code. You also see that any other tool that I'm using here, for example, this one right here, just above that is a PDF 417 code, also considered a one-dimensional code. And what you're seeing here is that you have a code that has the word Cognex Corporation encoded into it, and this tool is taking care of that. Same goes for the UPC label that you see here, just has numbers from 1 through 0, and then 1 and 2 repeat all the way at the end. And then the last one that I have, we'll get into in just a moment, is actually a two-dimensional data matrix at the top left-hand corner, and it has the text Cognex Corporation Insight Tutorials encoded into it. So you see here that I have my one-dimensional and two-dimensional codes, and the part, I'm able to keep up with all of those, doing a little positioning, and then I'm also able to decode what's encoded into each one of those codes, as you're seeing here. The tool is capable of doing that and bringing up the information very quickly. And if I scroll over, something you might be interested in if you're going to be using this is the timing that it's taking. The timing that this is reading right now, the total of 94 milliseconds. I am using an emulator, so the only reason why I wanted to show you this is basically so that you can see some relative timing. And that, for example, these codes right here, for example, are taking time that is negligible on my system, where the positioning tools are the ones that are really taking the most amount of time, as you can see. So what I want to do now is jump back into the slides, show you how what parameters you want to set and what parameters and what concepts you want to think about when you're setting this up, and then set one up with you so that you can actually take advantage of working with these tools. So let's jump back into the slides right now. Of course, feel free to stop me at any point in time, or make sure that across using the question manager that we have at the bottom of your interface there. So I don't mind interruptions, so please jump right in and interrupt me if I'm either going too fast or if you want to just ask me a question on what you're seeing. So one-dimensional readers. Basically, you draw a box around any code. The tool is actually designed and configured by default to just work. So it's actually kind of a really nice feature, and something that I really appreciate about this product, this DVT line of products, is that the tools have been designed and have been configured by default to just start working for you. So you'll see that when we get into them. Reader trains and determines the code type and the nominal orientation that you need. So it's really great about finding that code and telling you what's encoded into that code. Basically, the way it works is that it has scan lines going through the entire region that you're going to be drawing. And as you draw this region, these scan lines go through and try to decode what's inside of this particular code. Well, as each scan line goes through, what you want to find is which code is the one that's being decoded. When at least 5 lines match the same code, that's the code that's being reported out to you. So we don't need to run through the entire scanning of this region in order to get you that code. Okay, we can do it without running through the whole scan line, and that's one of the reasons why these particular codes and these tools can run very, very quickly. It's because we don't need to scan the whole region. Particularly when regions are relatively large, we don't have to wait for them to be done. Now, when you train this code and you open up this tool, you'll see a couple of different ways to configure it. One of the things that you'll notice is that by default, all codes are enabled, and the majority of them are enabled. Some are not, simply because of the way they work and the way they are designed. Those are ones that are actually likely to cause some, I don't want to say confusion, but some comparison similarities between similar codes. So some of those are disabled, but you can of course go ahead and enable them. And you can also go ahead and just disable any code that you don't expect. So if there's a particular code that you don't ever read, or you don't ever plan to read, you can disable that and make the thing be even more quick about decoding these parts. So if you just have one, you can actually choose read specific code only, and you can choose that particular code from this list of codes that you actually have, and not worry about any other ones sneaking into the mix. One thing that is a very important concept when it comes to, well, really anything in machine vision, but more specifically to these codes, is any type of thresholding, or the idea that we're trying to differentiate what is background and what is actual code. And this will play into something that will come up in just a moment, but the basic premise here is to make sure that we can differentiate between what is actually the barcode or the 2D matrix or the PDF 417 code that we're trying to see, and the background, which is usually white, but sometimes it's reverse polarity where you have a black background and a white mark. One of the things that threshold will allow you to do, and one of the things that you will be able to track as you're analyzing your region, is the intensity level of each of these pixels. So what you're seeing down the bottom here is actually a graph that's showing us the intensity of the pixels as you move across in a particular direction, namely in this direction that I'm drawing up here. As you move across in that direction, this is the change that you're seeing across each of those particular pixel locations. So as you move across, you're seeing that we have some dips, we have some increases, we have some very high peaks. Those are basically white areas where you see any of these high peaks, and where you see of these low valleys or troughs there are actually dark areas. And that's one of the things that the tool needs to do. Based on that, we're also going to try to increase our contrast and use contrast in order to differentiate what is background, what is barcode, and what is encoded into this barcode. So here's a good example and a not so good or bad example that you're seeing on the right side here. The premise is here that you have much larger differences between your peaks that you're looking at in the left image and your valleys or your very low points in these parts. The bigger the difference, the more contrast you have, and the more contrast you have, the easier it is to pick up what is the beginning of a barcode line and what is the end of a barcode line and what's the space in between or the background. Now, what I have labeled here as a bad example is not the best example, but the nice thing is that even when you have low contrast, you can actually use different strategies to pick out what is background and what is foreground, and we're going to do a little bit of that as well. There's a new method for differentiating between what's background and what's foreground, and that's something we call local difference. And what we're basically trying to accomplish with local difference setting, and I'll show that to you as well, is that we're going to want to understand that not all images are going to be pure black and white. In fact, most images are not going to be pure black and white. A lot of folks are using this under very adverse conditions, so they don't have the luxury of having a pure white label with black text or black marks on it. If you do, that's great. You know, that's just less for you to have to contend with. But if you don't, if you're working on this on a metal part that's being marked, or if you're working on this on a part that has very low contrast, you're going to be able to take advantage of something like the local difference setting here, which will actually allow you to track not just the overall difference between what's background and what is actually part of the mark, but actually what are the local or the nearby differences between the peaks and the valleys. So what it's attempting to do essentially is look at where your peaks and valleys are and make sure that it's not missing any other changes or any other potential peaks or valleys in the near region. For example, here's a good example of this right here. You have what appears to be a peak in this location right across, right near the center here, but then you also have what appears to be a valley here. And by using this local difference method, you're able to pick up on that even though you have very small differences or very small distances between the variations between dark and light transitions. So here's a method that you can use to counter that, to move away from that, so that you don't have to rely on very, very high levels of contrast. Some performance options that are available to you include smoothing, and what smoothing attempts to do is to basically try to get rid of noise. So as I mentioned, you're not always going to have this pure black and pure white background. You might have a background that isn't so white, or a background that is white but may have some specks of dust, some ink that has splashed, or some just minor pieces of noise all over the image. What smoothing will allow you to do is try to counteract those pieces of noise and really focus in on the major differences that you're going to be working with. Okay. Other things that you'll be able to do is change the rotation of these marks or these 2D matrices and really zero in on their orientation, regardless of where they're located and what their orientation is. You'll also be able to counter things like scale variation. When those marks start to shift, either because the part is actually moving closer or further away to the camera, or the printing process is being changed, or slightly changing, and your parts are changing in their print, in their printing aspect. So here's an example of smoothing, and some of the things that you should consider as you're enabling and disabling and configuring your tool is that different strategies or different functionality that you take advantage of may affect some of the time that you're seeing here. So one of the things that you're seeing here is that as you apply smoothing, and what smoothing basically does is it makes a scan line wider to take a larger area in order to figure out where the line begins, where one of these scan lines begins. So as you move here, if you have a scan line marked here in green, and you are to increase this particular smoothing and use additional scan lines, you see that we're adding some scan lines above and below, and we can increase that. And the basic purpose of this is to, again, get rid of any noise that might be in the image. You don't want the noise to be factored in to the location or trying to decode this particular mark. So you can use smoothing for this. Smoothing will take a little bit more time, and that's what I tried to highlight here. What you're seeing here is that on a 530 camera, with a width of 3, it's taking about 24 milliseconds. With a width of 25, 50, 75, as you can see, we're actually increasing the time significantly there. So this is something that you can take advantage of, but of course we always want to be aware of at what cost. In this case, we're showing just another example here of the 550 camera being able to do basically the same thing, but because the 550 has one of the fastest processors we have on these cameras, you're going to be able to perform this in just fractions of those times. So you're seeing that we're able to keep, even at 100 line widths here, we're able to keep it just at about 10 milliseconds. And these are right on those cameras. These are numbers that are coming out from the cameras, not from emulators. All right, and then finally, one of the last things that you can take advantage of when you're configuring this tool, which is something we're about to do, is the marking options. Basically, what kind of graphics do you want to see? And these are very useful because what they allow you to do is try to get an inside scoop as to how the tool is working and what information the tool is trying to use in order to make its decision or give you the information. So one of the things that we do here is, by default, we add a lot of these marks. But one other thing that you can do is, if you take a look at the bottom here, you can actually see what we call the threshold image. And what that threshold image allows you to do is basically see what it is that the system is actually seeing when it tries to make its decision. And in this case, you're seeing that it's doing a threshold to make the background completely black and the actual lines of the barcode completely white, so that we can bring out when something is part of our barcode and when something is part of our actual background. So here's what I want to do now. Before we jump into the 2D readers, I actually want to put one of these one-dimensional readers on the system itself. Let's jump back to the Intellect. And what I want to do here is actually start up a new product. I'm going to clear this out completely, keep the image that I'm working with here, but I want to start brand new here with a new product. So I'll click on this new product button. And what I'd like to do is basically start from scratch. There's nothing as part of my product right now. I have a few one-dimensional and two-dimensional codes here. I want to take care of them. You're going to find the tools we're going to be working with here under the Readers section. So I'm going to click on Readers, and you should see that expand. You'll see 1D root codes, you'll see 2D readers, and then you'll also see just below that OCR readers, which we'll get to. Once we jump into readers, the one we're going to use first is 1D code. So I'm going to go ahead and click on 1D code. As soon as I do that, I'm ready to draw that out there. I'm going to start off, let's just start off right here with code I2 of 5. I'm going to draw the region, just a rectangle around there. And one of the things that I always like to do is keep my eyes on my bottom result table here. One of the things that you'll see, as I mentioned, something I really like about these tools is that they're configured to just work. So I haven't done anything except draw the tool on the screen, and you're seeing that the code is already out there for me. So let's just take a look at some of the things that I'm able to configure. But as you can see from the start, we're doing a pretty good job of decoding this right now. Let's give this a nice intuitive name. I'll call it ID Interleave, which is the name of the code here. And I do have the option of setting up all of my typical tool parameters here, which include, of course, position referencing if I had a positioning tool. I did in my original display to you. I'm not going to set up a positioning tool. I just want to focus on the 1D reader for you here. So we have the shape, and we've already taken care of most of the shape here because we've drawn that line here. The next thing I want to do is talk about thresholding. Well, what thresholding allows me to do is basically have it run automatically, or what I can do is actually pick a thresholding method that I want. So I can actually disable this and say, hey, I don't want the local difference, or I don't want the threshold to be automatically trained for this. I want to make it very specific. And here are the options that you have. So you can actually have a fixed threshold, which will allow you to basically take advantage of a value that you get to set up for the threshold. Basically, a particular intensity value. Anything above that intensity value will be considered part of the background. Anything up below this intensity value will be considered the actual mark that you're working with. You also have percent of pass contrast. It basically analyzes the overall contrast that's happening inside of this region, and then it sets the threshold level according to that. You can also choose auto bimodal, which is another automatic method, which allows you to take advantage of any changes that are going to be happening throughout your inspection. So if you suspect that your environment isn't very tightly controlled, isn't being controlled in terms of lighting and in your optical environment, you might want to take advantage of some of these parameters here, which just allow you to be a little more flexible in the thresholding that is set so that you can keep up with these variations that I just mentioned. So here's what I want to do. I want to actually keep that the way it was, so I'm going to go ahead and keep that train threshold using local difference method. Training is something that you'll be able to do as well. You can train the type of code, and by default, what the tool does as you draw it, it actually just goes through and figure it out. Okay, so it's really nice in that way. It figured out already, as you can see here, that I'm using interleave 205, so I don't really need to do a whole lot here. If I didn't want that to happen, I could make it not trainable, and I can choose whatever code type I want. That's in case I don't want to be able to search through this list of items. I just want to know which code. I already know what code it is. I don't want to have the tool try to figure that out. I can do that, just set it up on my own. One other thing that you can do if you are using trainable is you can go ahead and click on the auto detect option so that when it is trying to auto detect, you can choose from which code types you're going to be working with. So here's a list of all of them. You'll notice that one of them is disabled based on the way it works. It's one that is likely to be considered when we're using the other RSS code. So we actually disable that by default, but if you want to, go right ahead and enable that. Or you can disable any one of these that shouldn't be allowed to be used in your particular inspection. So those are some of the settings you can take advantage of there. You notice that the code is also capable of learning whether you're using a dark on light or light on dark code. So if I don't make this trainable, I can actually just choose for it to be auto detected each time, okay? Or I can choose dark on light or light on dark. Okay? By default, we always make it trainable so that the system figures it out on its own and picks the right one. So if I actually apply this right now, what you'll see is that the system goes through and automatically takes care of that for me. All right, so performance, we talked about smoothing and how many lines you're going to be using. By default, it's just using one line across each one. Smoothing can be used if you want to. We keep that off by default for the sake of just being able to apply the tool and work as fast as possible. Other options include advanced, so that you can get some additional functionality from some of the more specific codes. For example, in the code 39, you can enable what's called full ASCII mode, so that you can actually use all uppercase, lowercase, and any other ASCII characters that can be included in the code 39. It was basically an update to the code 39 that included that. So you can use that as well. We also have something called quiet zone, and quiet zone is a concept that applies to most of these marks. That includes 2D marks, that includes one-dimensional marks, that includes characters as well. And what this allows you to do is basically be more restrictive or be less restrictive on how much white space or how much non-noise space there is around the actual code. So there is usually a guideline that the white space around these barcodes or these other marks has to be at least the largest width of these codes. And that's for the sake of not confusing some random mark, therefore actually being part of the code. You can be very restrictive on this, or you can be very loose about this, and that's what these two options allow you to take advantage of. Let's jump through on the rest of these. For the output, are you going to be using the default output or what's encoded, or you're going to use manual output settings? Basically, do you want to append or prepend something onto this code? Most folks just like to get that code out, but if they're using some kind of database or some kind of other system that requires some data or some text to be present beforehand, you can do that here as well. The default option will work for our purposes here. And then finally, what's it going to take for this to pass? By default, you'll see that the only thing that we require is a minimum contrast of 10, and that is really the minimal thing that you want to pass. Sometimes folks like to make sure that a particular code is actually being checked for. So one of the things that you'll notice down below is that I have a code here listed, and that it's passing. And that's great. It's basically passing because we were able to decode something. We don't know what it is, but according to our pass criteria here, you're able to see that it's there. You can see a code, and the minimum contrast is present, so 10 works. Well, if I actually wanted to check for a particular code, I could do that. I could check for, suppose I actually wanted to check for 1, 2, 3, 4, 5, 7, 8, 9, 0 instead of what you see there. If I do that, you'll see that not only does my code fail, I get the cause for failure, if you allow me to expand this just a little bit here, to be the code that we were looking for wasn't found. So there you go, this tool failed. Okay. Now, if I'm to match that code to what it was originally, okay, which is 0, countdown all the way to 1. Let's go ahead and do that. Let's do 0, 9, 8, 7, 6, 5, 4, 3, 2, 1, and I do that and apply that. You'll see that I am, in fact, passing, not just because my minimum contrast is being met, but the fact that I'm checking for a particular code. Okay, so that's something that you can take advantage of as well to make sure that not only do you have a code, but it's the code that you expect to find. And finally, grading. Grading is something that comes up more and more as we get into one-dimensional codes and 2D codes. Grading is something that allows us to take advantage of being able to grade these one-dimensional barcodes and these one-dimensional and these two-dimensional barcodes as well. So here's what I want to do. I actually want to stop checking for the code, and I'm going to go into the output parameters that you see here, and I want to actually enable some of this grading. And what this grading basically allows me to do is make sure that this code is adhering to certain criteria that the American National Standards Institute has designed and has approved and has basically taken advantage of in order to not only know that your code is being decoded, but how well is your code actually being represented when it's getting marked. I'm going to jump out of this. I'm going to actually make my way over to my original product that I was using, and I want to show you what some of these are. You're looking at the interleave code right here, okay? And this interleave code, I'm going to open that up, and if we go to the grading section, I'm going to go ahead and enable 1D barcode grading. And what that's going to do, once I click on apply, first of all, it enables all of these parameters. Second of all, when I click on apply, I want you to keep your eye on the bottom here. And what you're going to be able to see is that if I click apply, not only are you going to get, okay, the code that's encoded, you're going to get a grade value and a grade based on the quality of the printing here, okay? So why is this getting a grade of fail here, or why are we failing this? We were passing originally. Well, the reason why we're saying this is fail is that the barcode moved off of the tool and the quiet zone is not intact with the quiet zone that we've already, that we're checking for. So you see check for quiet zone here. Let's go ahead and disable that here. And one of the things you'll see is that we're back to finding it. Okay? So the idea here is that we're going to be able to get not just what's encoded into each of these codes, but also what we're going to be able to do is check how well these codes are being printed and basically monitor the quality of the printing that's happening. That takes care of our one-dimensional code. I'm going to draw one more on there for you, part of that product that we were working with here. I'm going to go ahead and draw one more one-dimensional code for the UPC. And again, one of the things that you'll see that is very nice is that it just works as soon as you throw it on there. So the code that we're decoding from this particular UPC label happens to be 1 through 0, and then 1 and 2 are repeating. I'll give this a nice intuitive name of ID UPC because that's the kind of code it is. And you'll notice that we have all the very similar parameters that you see here. Sometimes some parameters are not enabled, and the reasoning for that, if you go through some of these, let's see if I can find a good example for this for you. Here we go. Here's another a good example. Because we are using a UPC code here, you'll notice that I can't enable anything that applies to code 39. So sometimes you'll see that some parameters are available to you, and sometimes you'll notice that sometimes they're not available to you. And what the tool is capable of doing is dynamically change its parameters based on the type of code you're working with, so that you're not asked to set any parameters that wouldn't apply to the code that you're working with. Okay. All right. So Let's go right ahead and move on to 2D readers. Jump back into the slides here. I want to show you 2D readers. 2D readers are another set of marks that we can take advantage of. They're becoming more and more popular, starting off with data matrix. And the basic structure around data matrix is that we're going to be able to take a look at this mark that's being presented and analyze what's encoded into this. And here are some of the things that you should know about the 2D matrix. Basically, the clocking pattern is this alternating set of dots on the opposite end of what we call the finder pattern, which is what allows the tool to actually, or the camera to actually find the mark first. And then the rest of this stuff, the stuff inside, is the actual data, what we call the modules or cells. This stuff is what designates what's inside. And anything outside of that, you're seeing me point here, is the quiet zone. The quiet zone is basically the area that can be removed, or that should be removed. There should be no data or no marks around it so that we can find it and decode it properly. It also has other information like module cell and some guidelines. Each cell represents one bit of binary data. You should know that. And the quiet zone has to be at least the size of a single cell width and height. So around this area that you're seeing here, which I'll try to highlight here, there shouldn't be anything around this data matrix so that we can actually find it and decode it properly. Other information about the finder pattern and the crossing pattern that you see here, it's basically the outline of your data matrix tool that I'm attempting to highlight here. It's what allows us to very quickly find it and figure out where it ends and where it begins. And finally, the data region. Not necessarily the most important part, because if you don't have the finder L pattern here or the clocking pattern at the other edge, you won't find this actual tool. But it's, of course, where the bulk of the information is stored. It's inside of that outside region that I am highlighting at this point now. And this information here is very valuable. But one of the nice things about the data matrix, and one of the reasons why it's becoming more and more popular all around, is that you can actually degrade or obscure some of this data region here and still have it be part of the actual data. One of the things that you'll find is that you'll actually be able to block or distort a significant part of this area or of that finder pattern and still be able to decode that. I've actually seen examples of folks working around almost 50%. I've seen about 40% of obscurity or 40% damage on one of these guys and still be able to get the data out. So that's one of the reasons why it's becoming more and more popular. All right, so let's keep moving here and talk a little bit about what it takes to get one of these things marked or presented on a part. Depending on your needs, on what your customer's needs may be, they may be marking this on a label, which is kind of nice because it's usually done by inkjet printing. But if you're not using a label, if you're using them to mark metal or other surfaces, you're going to have to think differently about the way these are marked, because chances are they're going to be subjected to very adverse conditions. So what you're seeing here is just an example of the different marking methods that are available. They include things like laser marking, very useful for things like medical devices. Inkjet, probably not done on metal devices or any device that's going to be done or subjected to adverse conditions. However, dot peening is very popular for metals, particularly in the aerospace and automotive industry, so that they can withstand a lot of abuse from extreme temperatures and other processes that they must go through. And electrochemical etching is another one, which is used to encode on metal. But these are basically areas where things need to be very, very small. This is another very popular one on medical devices as well. Mark placement is, of course, important because you need to worry about basically the size and how it will be presented to our cameras. And you also need to worry about the quiet zone, as I mentioned, making sure that not only do you have enough space to install your mark that you're seeing here, but also make sure that you can actually take advantage of the quiet zone that needs to be around them. Also, curved surfaces tend to pose a particular challenge to folks for printing and also for decoding, but the nice thing is that if we can get this lit properly, we can handle any of the skew or the aspect ratio changes that are happening here, even when it moves into the low contrast areas that you're seeing down below. Readability is going to be affected by a lot of different factors, poor focus, washed out images. But the nice thing about that you'll find from these tools is that you're going to find that they're actually designed to work under very adverse conditions. One of the things that you'll find within Cognex products is that we're really not going after markets like UPC labels on consumer products at a supermarket. Those markets are really really well taken care of by the folks that are serving them, to be honest with you. And they don't really pose that great of a challenge. They're usually addressed with laser scanners that are very very easily accessible, and the parts are being presented under very, very high contrast. So you don't really need to worry about having a method to decode them, because they're just out there. They're very evident to the folks that are working on them. But what we are going after and what we are trying to serve is the market of folks or the people that are trying to work under very adverse conditions. When their lighting environment isn't optimal, when their contrast isn't optimal, when they have situations where either the camera is being affected by the environment or the environment just isn't very friendly. I'm talking about environments where you have very low contrast like you see here, or here when you have very, very dark images, or when there's non-linear lighting that you see presented here in the bottom left-hand side, where you might have some dark on light background, but then you might have some light on dark background within the same code. So those are the kinds of things that we're hoping to address with all these tools, and what you'll find the tools can actually take advantage of. One of the things that you'll find also with 2D matrices and 2D parts is that you actually do need a CCD or a CMOS scanner, basically some kind of camera. You can't address the need to decode 2D matrices with a laser system, with a laser scanner or with an infrared scanner. It does have to come out of an image or an image process. So, as I mentioned, these are some of the situations where we're hoping customers can take advantage of our tools and of our products, where they have very adverse conditions that still need to be addressed. See some examples here with some hot spots, uneven background, some very low contrast, some changing or skewing of the barcode of the 2D matrix here, some curved surfaces again showing up here, overexposure where we have just a lot of light coming back up to the camera as well. So finally, the 2D matrix is very advantageous to folks that are looking to mark their parts, and that's primarily because you can fit a whole lot of information, up to 3,116 characters or digits in the mark. You can fit a lot of information into a very, very small area. That's really what it comes down to. Using error correction within the use of these 2D matrices, you can get up to 50% code degradation or basically damage to the code before you can stop reading the code. And the basic premise here is that even though this code will be very badly damaged, you'll be able to read it or get the information out because there's a lot of redundancy built into this error correction. Many formats are available, square and rectangular, basically for the purpose of real estate adjustment or depending on the type of information you need to work with. ECC 200 is preferred, and that's basically the latest version of the error correction code that's being used in these cameras. And it's basically for the purpose of being able to have this code damaged or skewered and still be able to read it. It is preferred for that reason. Beyond that, there's something called grading and verification. I introduced you a little bit into that, but 2D matrices and beyond really lend themselves even more to this stuff because since this is essentially the industry or many industry standards, including the aerospace and the automotive industry, they like to use this type of code to mark their parts. These folks are very interested not just being able to decode or put that code on, they're also very interested in being able to read it and have it be printed with controlled quality. So some of the things that you'll be able to analyze and get information about are the symbol decoding, and if we were able to decode it, the overall contrast, something called the print growth, the axial non-uniformity, as well as unused error correction, all factors that play a role into how well this code is being presented to the camera. Other parameters that are not necessarily graded but are important are the dot size and the dot offset, and that's basically based on the level of resolution. How big are these dots showing up in front of the camera? Because you need them to be at least 4 pixels large in order to get reliable and repeatable results. Actually, I'll take that back. I'll say that you can probably get good results if you're using 1 pixel or even 2 pixels for the size of these dots. But we like to tell folks you don't want to really be pushing on the lower end of this limit. You want to be able to really grasp onto that and not worry about, are my dots going to be seen by the camera? Okay, so we tell folks that in general you want to keep those dots at least 4 pixels in size. But I've seen it work with smaller dots. But if you don't have to do that, I don't recommend it. All right, so industry specific does apply to the 2D matrix because some folks are so into the direct part marking that they develop their own standards that must be met. And some of these, for example, the automotive industry uses the Automotive Industry Action Group, or AIAG standard that they can use to measure how well these codes are being marked. The Department of Defense also uses the DoD standard. The aerospace industry uses the IAUG standard. All of these are going to be able to be measured by the tool. So take a look at what we're going to do now. What I want to do actually is show you one of these in action. A lot of the parameters that you'll find are very similar to the way the one-dimensional tools work, so I won't spend a whole lot of time with them. But I just want to show you what it takes to get one of these up on the screen. So I'm going to jump right back to my Intellect interface here. I'm going to add another tool here, part of my 2D readers this time. I'm going to take that 2D reader and put it around the data matrix here. And I'm going to call this ID 2D matrix here, just for the sake of intuitiveness, I should say here. And one of the things that you'll notice, again, I just drew this and this thing is already working. So technically I don't even need to go in there and configure anything, but I just want to show you some of the differences here, that you can select a barcode type, whether or not it's a square or rectangular matrix, and what is going to be trainable, or if you don't want it to be trainable, if you want to choose the error correction that's built into it, okay, or have a range, you can see that here. You can also choose the symbol size yourself, depending on the symbol type that you've chosen. And in this case, you're going to be able to choose all of these configurations that you see here, or just have it be auto-detectable. And you can also choose the dark modules or light modules, or auto-detect the outline. Basically, are you looking for a white mark on a dark background or a dark mark on a light background? And how much flexibility is there going to be when it comes to lighting? That's another thing that you're able to choose here. Beyond that, is it a mirrored image? Is it a normal image? Or do you want the tool to auto-detect it for you? Okay. And do you want the image to be marked, or do you want to see some of that information out there? If I choose mark cells, you'll actually see that I'll be able to mark the actual parts of the image here that I'm going to be able to do. So one of the things that I'm going to be able to do is choose the different types of image markings that I'm going to do. And in this case, I'm going to be able to choose what graphics are going to display. Advanced tab shows you a lot of the same parameters here, but now you're going to be able to get into, well, how much skew are you going to allow? How much rotation are you going to allow? How much non-uniformity? How much variation, or how much how tolerant you're going to be when it comes to this code. And then, of course, the results. What information are you going to get, and what is this code made of? So you're going to be able to get symbol type information, symbol size, all the information you probably wanted to know about that code, as well as how well it adheres to the isometric, the AIM standard that you're going to be able to actually compare against. And finally, what is it going to take for this code to pass? Very similar to what we were working with on the one-dimensional codes. You're able to match the string exactly like we were able to do, or match just a portion of that string as opposed to the whole string. So do we want to check the string? Do we not want to? If you don't care what the string is, if you just want to make sure that you get a string and maybe pass that string off to some other device, you might not check for the string. But if you want the Intellect system to actually make the decision itself on whether or not the string is intact, then you would be able to take advantage of that right here. And that's it. That's what it's going to take to get a two-dimensional tool up there and reading that code, decoding that code for us. The last thing I want to talk to you about is the optical character recognition capabilities of the system. And that basically allows us to, well, take a look. It's going to allow us to make sure that we can take advantage of the optical characters or alphanumeric characters that are going to be printed. Now, the end part of this data matrix some things that you should know about when it comes to the advanced parameters. So I showed you what some of those are, but basically you're going to be able to take advantage of analyzing the skew, the border integrity, the quiet zone, is it intact, or how restrictive you're going to be on that, how rotated it is, or any rotation limitations that you want to apply, as well as any of these other things like non-uniformity, probe width, the clean area around the actual tool or the actual mark, as well as the minimum gradient or the intensity that has to be found between the actual mark and the background as well. Advanced parameters also include the search parameters and the cell sampling that you're going to be using, and you can take advantage of those. The nice thing is that we brought out just a little bit of a blurb here for you, just to give you a brief idea of what it is. But all of this stuff is documented, so you'll be able to take advantage of looking at that and some examples of that in the actual help file. All right, so the last thing that I want to sort of end with when it comes to the 2D matrix and the 1D code is that you can take advantage of the one-dimensional linear codes because they're very popular, they're very easy to work with, they're very popular, and they allow you to just put any type of one-dimensional code that you want on there. However, they come at the cost that it's relatively speaking older technology, and what that means is that it hasn't been optimized for real estate or for very small applications just yet. And when it comes to that, it most likely won't be. You'll be able to rely on things like 2D stack linear barcodes and also 2D matrices. And one of the things that you'll find when we do just a live comparison between these is the fact that if you take a look at all of these codes that you see here, they actually all have the same information encoded in them. But as you can see, a data matrix takes far less real estate and is a lot more robust in terms of being prone to noise or adverse changing of that code or obscurement of that code. So that's why, in general, folks are really leaning toward the 2D matrix. If you go to, well, a good example of this, if you go to a local supermarket, a lot of times you'll see not just a barcode on all of these products, but you should start to see a lot of matrix codes nowadays being used in a lot of these products for this very same reason. All right, so one of the last things you can see here is that you're going to be able to include a lot of information into this over a very small area. And the last thing I'm going to show you is the optical character or the readers. I want to show you this in action before we jump into the slides. I'm going to change my product here to the OCR version of my product, and I'm actually going to load up just slightly different images here. And the reason for this is that I want to actually show you that I'm able to get the image loaded, and I'm able to use a product here to show that I'm actually able to read based on the training of these characters, the characters that are actually on the screen. So if I cycle through these images, the next one I'll show you is able to keep up with the slight movement here. I have done some positioning to keep track of this part, and I'm able to decode the whole new string here that you see here, which is AEU81. And I'm able to go ahead and move on to any other strings that I have here, and I've actually allowed this to train for any variation, and that's what you're seeing here. Let me zoom in just a little bit to show you that this A is not quite the A I originally trained. It does have a little bit of a variation, but I'm able to still detect that as the letter A. The last one I have here is one that I have purposely gone out and made significant changes to these characters so that they don't look like anything that we've actually trained. And what you're seeing here is that these characters are showing up in red, showing that they are not passing, except for the last character, which is one of the ones I trained. And if you look below, you'll see that the string is showing me that I have question marks for all of the characters that are unknown to the system. Now, the nice thing is that the characters are only unknown to the system because I haven't trained them. But if I am to train them, those characters will then be known and will then be identified. So I'll show you how to get that up and running as well as we walk through here. And we're back to our original string that I wanted to read. So let's go into the optical character recognition that you're able to perform, and I want to actually put that together on the tool and show you how that comes about. So optical character, the setup is basically draw a region around the characters you're looking to work with, and the tool will actually find the character and draw red graphics around any characters that you have not yet trained. So the first thing that you're actually going to see is red graphics when you're working with this tool. And sometimes folks look at this and go, boy, I thought this was supposed to be green and it was supposed to be working right from the start. Well, the first time you draw the tool, you have not yet trained any characters. So Intellect is now saying, I've got characters here, but I don't recognize them. What do you want to do? And I'll show you how you go about training those characters. Beyond that, the OCR tools are also going to have a significant amount of parameters, but the nice thing about these parameters is that they are set up so that they will work by default under most conditions. I'll show you how to get in there and modify some of them and what they do when you might need them. And finally, once you do get some of these characters trained, you start to see the green graphics go around these characters. You enter the characters as part of the training string, and once you go ahead and click on Train Now, which is what you're seeing here, you're going to be able to go ahead and train those characters and get some nice green graphics around them, showing us that we are able to train them just fine. So you do want to keep an eye out for green graphics once you go ahead and click on Train. One other place that I like to spend a lot of time is always in the character info location. And the reason why I like to do that is because under the character info, I'm able to see, well, basically all the characters that I'm currently working with, what their identity is, and very importantly, what their score is, because that's one of the major considerations that the tool makes when trying to figure out whether a character is passing or failing. You're seeing that we're getting scores nice and high here in the 90s. I get some other information like how wide my characters are, how high they are, and their overall threshold for these characters. So just really some good information about the characters. You want to keep your eye out here to make sure that you're getting the kind of results that you expect to get based on the image that you have in front of the camera. Finally, you can get into some more specific matching criteria so that you can really try to help the tool out, first of all, or just make the tool that much more efficient and not prone to any confusion with other characters. So first of all, one of the things that I want to show you here, and one of the things I will be working with and setting when I set this up, is the minimum match score. And what this score does is it says, for any of those characters to pass, they have to at least achieve, in this case, a 70% score. So remember back into my character info here? Well, each of these characters is getting well above the 70. They're getting very close to 100 here for the score. So what you're seeing is that each of them is going to pass. Well, if any of those characters didn't show up correctly or wasn't recognized, they're going to get a score significantly lower, and this is where that minimum match score comes into play. You can also do things like say, I only want to extract a certain number of characters. So suppose you have a string under the camera that's 32 characters long, but you're only interested in the first 8 characters. You can do that. You can say, show me just the first 8 characters by enabling this. Or you can enable something called auto fielding, which allows you to basically dynamically change the number of characters in front of the camera without having to go reconfigure the tool. So it's actually very efficient in the way it works. Now, here's one other concept that is very important. Suppose that you had, for example, a character that started off and had this, for example. Okay, lot, very popular application in OCR, taking out the lot code, and then you had a number, so 980764, for example, and you knew that every time you worked with this string or this application, the word lot would appear followed by a space. Well, what you can do is you can say, for each of the positions that you're going to be working with, for example, position 1 can be any. Well, by default, all positions can be any characters that you currently train. Well, what you can do now is you can say, hey, I know that the first 4 characters are going to be LOT space. So what I can do is I can say for position 0, I'm going to choose that, position 1, as you can see here, I'm going to choose that it's going to be some other character, and I'm going to type in the letter L right here because I know that that particular position will always have the letter L. So that the tool doesn't have to go through and try to match against everything that you've trained. It just helps the tool not have to do as much work and eliminate any other potentially confusing characters. at the same time. So it's really a great thing to take advantage of if you know a little bit about the string that you're going to be getting. All right, so let's take a look at something else that you can do, and it moves into the realm of what some folks might call verification. And what this allows you to do is basically not only does it allow you to check each of the characters, the score for each character, it also allows you to check if you in fact have the actual string that you're looking to find. So this moves into the realm of verification. You're looking to verify that the word cognix is actually printed. So that's what you're able to do here. You check match string, and then you're able to say, I want the word cognix to appear. And if anything else other than that word shows up, the tool is going to fail overall. It's a great way to check to make sure that you're seeing what you expect to see. All right. So before we end here and we go through the summary, I'd like to just show you what it takes to get one of these up and running here. I'm going to go back to my original image here. And what I'd like to do here is just go into this image right here. This is what I'm going to use to train. Okay. Let's go ahead and get rid of my OCR characters here. I'll delete that. Okay. And the only thing I have left here is the positioning tool. This positioning tool is what I'm going to use to help me track the different locations where these actual characters are going to show up. So let's go over to the intellect side of things. And I want to show you that right now the only thing I have in my application is actually the string of characters that I am hoping to train, and this fiducial or this mark here that I'm going to use in order to make sure that each of them is found. So I just want to show you that in each of the images, the strings are located in slightly different positions. So what I'm going to try to do is use that to tell me where the strings are being found so that I'm not hopping all over the place here. All right, so let's put in OC Reader tool. Here's one of the things that's very important about configuring this tool, and something that tends to get people when they first use the tool. Most tools that you use up to this point require you to draw a region, a single region that is done with one quick stroke, almost diagonal here. So a lot of folks are tempted to just go diagonally here and draw this, and then they have this other stroke that they need to complete. Okay, so here's the best way and the right way to go ahead and get this running, because if you do something like that, you'll see you're not going to get the kind of graphics you're looking to find here. I'm going to cancel that and go through that one more time. I want to show you what it takes to put this on the screen. You're going to want to draw your first stroke by holding down the mouse button. So I'll do that right now by clicking the left mouse button and holding it. And draw down, as you see here, and then releasing the mouse button for the second stroke across in the direction of the string. And you're going to end up with a rectangle, but it's a two-stroke process, and that's what folks kind of get thrown off a little bit at first. But once you do that once, it's actually very easy to perform. So I'll go ahead and click one more time there to finish my stroke there, and I'll click the mouse key, and what you're seeing right now is that my tool has drawn itself around the characters that I'm looking to train. Not only that, I've got some red graphics around all of those characters. That might look alarming at first, but it isn't, because this is just the beginning. That just tells me that Intellect was able to find the characters and they're not yet trained. That's all it means. So here I go. I'm going to go ahead and give this tool a nice name here. Call it OCR characters here. Okay. And I will have a position reference. I'm going to use the position of this mark here so that this tool knows where to place itself each time. So I'm going to go ahead and, instead of using the system frame, I'm going to use this tool by the name of position characters. And I'll apply that. All right, what else can I take advantage of here? I have some options here. By default, we're using trainable OCR. Okay, you can use fixed font OCR. What you can do with fixed font OCR is basically load some characters that are already trained. And these characters, fixed font OCR, means that they're going to be part of some characters that are part of the grand scheme of machine readable characters. Characters that are actually designed for machine vision, so that characters don't look like one another in their place. So we're going to use trainable OCR in this case. We're looking to train the characters. We're not going to use a canned font set. We're going to use trainable OCR. I'm going to use black text on a white background, and I'm going to show the characters in the original shape. I can show something else. I can actually show something called show thresholding end characters. And what that does is it gives me a visual to see what the system is actually able to detect as part of its thresholding speed. So what you see here is that the tool immediately takes the original grayscale image and changes it into a black and white image and shows us what it's able to pick up. Now this is great for setup, and this is great for maybe some potential troubleshooting that you might have to do, but during runtime, folks generally don't show this just because it kind of takes your attention away from the actual string. So users don't typically like it or are distracted by it. But I'll put that out there because I do want to show you how it does work as you're setting it up. So that takes care of options for us. What about extraction? Well, extraction is useful when we don't actually have the string or the characters that are being recognized. So what I'm going to do is I'm going to go back to options. I'm going to show just the unwarped characters here. Okay? And here are the characters that we're using here. And what I'm going to do now is actually show you the extraction that allows you to perform either searching. So suppose you went through here and you didn't find the characters that you were looking to find here. Well, what you're going to be able to do is choose the minimum size, the maximum size for these characters, the maximum spacing for these characters, that minimum pixel count for these characters. Essentially, you're going to be able to get into the finer details of each of these characters, configure what they are, and be able to find them. That's the premise here. Be able to eliminate noise or stuff that just isn't a character out of the equation here. So you get to also set up your spacing and also some more advanced weighting that gets done, statistical probability that gets pulled into the whole equation here. Where is it highly likely that your characters are going to vary in size and in shape, or it's very not likely that this is going to happen. So you can set some of these parameters, and notice that they're more gradients as opposed to yes and no values here. So if it's relatively likely that your characters are going to have equal spacing, then you would move that up to high. If it isn't likely, then you will keep that at low here. These settings are by default set to very low just so that we can counter any potential significant variation here. Beyond that, what you're going to be able to do is take advantage of the training tab, and this is what we're going to work in right now. We're going to basically create a brand new font, and that's what the default setting is here. Okay? And the training string that I'm going to use is going to be, what is it that I'm going to label each of these characters that you see here? That's the basic premise here. So I'm going to go ahead and type in capital A, capital E, capital U, 1, 2, 3, 4, 5, 6, 7, 8, 0. And those are the characters that I'm going to train. Now the characters that I'm asking the tool to train are any failed characters. Okay? Well, technically right now, since I don't have any of them trained, they're all failing. That's why they're red. So all of these are going to be trained. I'll show you in just a moment that I can actually take advantage of the ability to ignore a character if I don't want it to be trained. Okay? So here's what I'm going to do. I'm going to click on Train Now, and I'm going to walk you through the process of what happens when I click Train Now. Train Now, the first thing I'm asked to do is give my font a name. Okay? So font 1 is okay, I suppose. I like to use more intuitive names, so I'm going to do SNT for font, and then I'm going to call it Miguel's font. Okay? All right, so Miguel's font is in place here, and I'm going to click OK, and now I have Miguel's font created, and I have Miguel's font being used, and you'll notice that I have all of these characters now in very nice green here. They're all trained now. That's why they're all in green, and you can see that the string coming out of this is the one that I just trained. And it should be. I mean, it is the character that I just trained, so I should not only see that this is working, I should see that my character info reports very high scores of 100, and that's what I would expect, especially since these are the characters I'm training. Okay? So the inspection result is overall pass. I can see information about all of my characters here. The next thing that I want to do is go on to my next image because I want to show you what's going to happen here. I'm going to move over to just one image over, and you'll see that I in fact do have my characters, green graphics, and that tells me that everything's going great. I'm going to look at character info because I'd like to keep an eye on there and make sure that things are working the way I expect them to. I got A, E, U, 8, 1, which are the characters that I see in front of me. So that's all working great. Good, getting nice high scores here. Let's move on to the next one image here called image number 3. And in image number 3, you'll see that everything is passing except the L. Now, why isn't the L passing? Well, let me show you why the L isn't passing. I'm going to go back to training, and I can actually go ahead and manage my font or see what's going on inside of my font. If I click on Manage List, what pops up is the Font Explorer here. And what I'm able to do is see that I have two fonts. One of them is called Class Font. One of them is called Miguel's Font. Let's open up Miguel's Font and see what's in there. You can actually see the characters that are trained, okay, and parameters pertaining to those characters. You will notice that I do not have the letter L trained. Therefore, that's why I'm getting failure for that letter L. I'm getting a red graphic. So I'll say, okay, let's go ahead and close that. Let's go ahead and close that. Why don't we just train the letter L so that it can be part of our whole font? Here's what I'm going to do. For training string now, I'm going to remove this, and I'm going to type in question mark, capital L, question mark, question mark, question mark. And what this is telling Intellect to do, first of all, train only failed characters. Second of all, ignore any characters in the positions that have a question mark. So the only thing I'm about to do now is train the letter L. So I'll click on Train Now, and you'll see that the letter L is now in green. It's part of my font now. We can verify that by going back to Manage List, open up Miguel's font, and you'll see down at the bottom the last character I trained is in fact the letter L. Alright, let's finish up here because I want to show you some more things you can take advantage of. So we're done with training, so the letter L works great. So everything up to this point works very nicely. All the characters I trained, the next image over, one image, we just trained the letter L. Here's something else that's happening here. We're getting some characters passing, some characters failing, and some characters that are passing aren't actually the characters that I originally trained. So what can we do about this? Well, one very simple solution to this particular example is something called minimum match score. And right now what I'm saying is that my minimum match score is 70 for each of these characters. Let's take a look at character info and see what scores these characters are actually getting. Character info shows me that my 0 is getting a score of 80.4. Boy, that's just above 80. My E here, which is kind of weird, okay, for an E. It's actually a sigma symbol, resembles an E, but it's not quite the E that I trained. Well, it's getting a score of 71. Boy, that just exceeded the 70 threshold that I had set up. Okay, you'll notice that the E and E that are being attempted to be matched, you get a score of 55 and 63, significantly below 70. Here's what I can do to alleviate some of this. I can actually just go up to matching and bump this up, say to 85 perhaps. Apply that, and you'll see that the only thing that passes now is the correct 3 that I have here. When we look at character info, you'll see that the only thing that is passing is the 3 that is getting a 95.6. Everything else well below my 85 is not passing. And beyond that, I can also take advantage of modifying really that as I see fit. So for example, if that 0 was okay to be substituted, well, 80 might be a good value to continue to use here and keep that 0 passing. And the last image that I just want to show you an example of here is this one right here, where we're actually getting a U being rejected here and the number 9 being rejected here. I think you'll find that the U is being rejected for basically the same reasons that my letter L was being rejected here. And then, the number 9 is being rejected for the same reason my letter L was. I never trained the number 9. I went all the way up to 8, as you can see here. I'll move this a little bit. I never trained the number 9. I did train the U, but I didn't train the U with that little accent above it. So when I show you that image, you'll see that the U is getting a low score, and the 9 is probably getting an even lower score. Let's take a look at character info here. You'll see that my U is now being considered as a 0, and I can see where that might happen. That accent is almost joining the top part of the U there, and it's getting a score of 70.1. And then the last thing that's happening here is that my character here is showing up as the number 4. It's not a number 4, it's a number 9, but I don't have a number 4 trained. Let's do this. Let's go back to training. Let's alleviate both of the situations here by training this particular version of the U, and finally including the number 9 as part of our training. So I'm going to ask the system to ignore the first 2 characters with a question mark here. Then I'm going to supply the capital U here, have it ignore the number 8, and then I'm going to have it train the number 9 as part of this. I'm going to click on Train Now, and as soon as I do that, I'm back to nice green graphics. Character info is identifying these very nicely for me as the letter U. You'll see that the 9 is also being identified very nicely here. And you'll see that actually all of these images should now be passing except the one that I configured not to pass, which is the one that doesn't have the actual characters that are originally trained. Okay? Close variations perhaps, but not the characters that I want to work with. So you'll see that their scores are significantly lower. So you'll see them fail in this example right here. Okay. All right. That wraps up our OCR character recognition system here. And the last thing that I actually want to do with you is, of course, take your questions and go through a summary here and show you anything that I might not have showed you that you wanted to see here. Let's take a look at the summary real quick, and we'll jump right into that. We talked about direct part marking. It's based on making sure that a lot of factors are in place, specifically the mark that you want to use, choosing the right mark that you want to use based on your needs, as well as getting that mark printed or marked in the right location and under the right conditions. Ultimately, the success will depend on the capability of the reader to successfully read the mark at all stages. So sometimes these marks get printed and they go on a store shelf. They don't really get much, go through much damage or go through many processes. A lot of times these marks are printed on, for example, engine blocks, which are then machined, which are then washed or acid washed or cleaned under very, very adverse processes, and that mark has to be able to stand through that process. Characters, when we talk about optical character, must be repeatable from one image to the next. You'll get best results when characters are repeatable, and you're going to do that by being able to actually control the way these parts are being presented to the camera. If you can, as much as possible, we recommend that you use what we call OCR-friendly fonts or machine vision fonts, like OCR-A, which is the one we were using, OCR-B, and semi-fonts, because they are specifically designed to allow you to have characters like the O and the 0 not look like one another, or look as different from one another as possible. Beyond that, you're going to want to make sure your pixels are at least 20 and 30 in terms of height and width. But what you're really looking to do here is make sure you have good resolution. Now, can you get characters to read if they're less than 20 and 30 pixels for height and width? Yeah, the truth is that you can, but you're going to get better results the bigger those characters are. Okay, the better resolution you have, the better results you're going to get, the more reliable results you're going to get. Okay? Use OCV, the match string capability of optical character reader tools, to make sure that you eliminate any mysteries, to make sure that you're actually matching the exact characters that you're looking to. Okay? And make sure that you're keeping an eye on your accept threshold, your minimum match score for each of these characters, because primarily that's going to control whether these characters are passing or failing. All right, folks, so that brings us actually to the end of our presentation here. We're just a little over an hour here, and I'd like to take any questions you might have, or if you'd like me to show you anything on the actual Intellect product itself, I'd like to do that for you and let you know about some of the other options you have when it comes to getting more information about these tools and about our classes and our process. How's it looking out there for you folks? Do you have any questions I can answer for you?
I don't have any.
Okay. Thanks, Mark. I think Jessica just signed off. So I think at this point, I'll let you know that you can always reach me at miguel@cognex.com. And you should also take advantage of some of the other classes that we have available, from live classes to these online classes to previously recorded online classes. Make sure you head over to cognex.com and click on the training link, and that'll give you access to everything that we have. So Mark, hope you'll be able to join us on any other of our classes. Do you have any other particular products that are, or particular tools that are important?
You know, as I was telling you, I'm not really using the OCR, but a lot of the same stuff still applies, so I'm trying to pick up on, I'm trying to understand like the thresholding thing a little bit better. trying to figure out how to optimize my images, block out noise, and a few things like that.
Gotcha. Gotcha.
So,
you know, a lot of that, I was going to say, a lot of that comes from, it's going to come from